Welcome to this video. We are going to continue solving integrals from the textbook. The textbook is Stewart Calculus Early Transcendentals, the 7th edition. And we're on section 7.5, Techniques of Integration. Okay, so we left off on 34. Let's begin. We have this integral from pi over 4 to pi over 2, 1 plus 4 cotangent x over 4 minus cotangent x dx. Okay, so I personally don't like cotangents, so let's write it in terms of sine and cosine. Okay, so the limits of integration are the same. I'm not going to do a substitution yet. I don't even know if I need to. So let's write it as 1 plus 4 sine x over cosine x over 4 minus sine x over cosine x dx, like complex fraction like this. Okay, and now I see that maybe let's multiply by cosine on top and cosine on bottom. Okay, so when I multiply by cosine on top, we get cosine x plus 4 sine x. The bottom, when we multiply by cosine, it's 4 cosine x minus sine x. Okay, now what do we do from here? Maybe a substitution. Maybe let's let u be 4 cosine x minus sine x. Let me write that. Du would be minus 4 sine x plus cosine x dx. Did I write this correctly? I did not do this correctly because this is cosine x over sine x. I wrote tangent. Cosine x over sine x. Okay, so don't make the same mistake I did. Okay, so let me cross these two out. So I want to multiply by sine on the top and bottom. Okay, so it'll be pi over 4 to pi over 2 sine x plus 4 cosine x over 4 sine x minus cosine x dx. There we go. Now I can see a substitution. We let u be 4 sine x minus cosine x. Du would be 4 cosine x plus sine x dx. Very convenient. We have that on the top. So we can rewrite our integral as du over u. What about limits of integration? This is the definite integral. Well, when x is pi over 4, u would be what? So let's even write u is 4 times root 2 over 2. This is when I'm plugging in pi over 4 minus root 2 over 2, which is 3 root 2 over 2. Okay, so, and then when we plug in the upper limit, pi over 2, we get 4 times 1 minus 0, which is 4. So our limits are 3 root 2 over 2 and 4. Okay, now we integrate. That's just log of u, evaluate from 3 root 2 over 2 to 4, which is log 4 minus log of 3 root 2 over 2. And that's my answer. Okay, started off a little rough with a simple mistake, but let's continue. Okay, 35. We have an integral of cosine 2x, cosine of 6x, dx. This is a 6. Okay, so at least in math 2B at UCI, you don't typically learn how to solve this type. It's just another trig identity in the trig integral section. When you have a product of two cosines, there's like a product to sum formula or product to difference formula. I think that's what the identity is called. Product to difference identity, something like that. Okay, so let me just use the identity. It'll be half integral cosine of the sum of the two, which is ax, okay, plus cosine of the difference of the two. So if I do 2x minus 6x, it'll be minus 4x, okay, all by dx. Okay, so how do we solve this now? this is easy. This one we can actually, let me do one more step before I integrate cosine of ax. We know cosine is an even function. So when we have cosine of negative 4x, since it's even, it's the same thing as cosine of 4x. Okay, now this is easy to integrate. It'll be half times an eighth sine 8x plus a fourth sine of 4x plus c. That's my answer. Okay, next, this one's actually very easy. Integral negative pi over 4 to pi over 4 of x squared tangent x over 1 plus cosine squared x dx. How do we solve this? I immediately can tell you this is 0. Okay, hopefully this gives you a clue if you weren't able to solve it before. Otherwise, remember, I said this in the previous videos, I'm sure. When we have limits from minus a to a, so in this case, minus pi over 4 to pi over 4, you should always check if the function is even or odd, so you can make your life easier, hopefully, especially if it's an odd function. And in this case, it is an odd function because, how do I know that? Well, x squared is even, so when I remember an odd function, f of minus x is minus f of x. Okay, so over here I did even, where it's f of negative x is f of x. So that's what I did over here, but here it's odd. I want it to be odd in order to say it's 0. Okay, so this portion is even. Tangent is odd. Hopefully you remember the graph of that. Tangent is an odd function. And then 1 plus cosine squared, this is even, because when I plug in negative x, cosine itself is even, so it'll be positive. So the whole thing would be, when I plug in negative x, there'll be a negative sign from the tangent. The tangent is odd. So that's how I know this is 0. Okay? So you don't even have to do anything. Especially when it's something complicated like this, you should, and then the limits were a big hint, you should always check if it's even or odd. Just make your life easier. Okay, I think I can squeeze one more in. This one's pretty easy also, looks like. We have tangent cubed, secant squared. Okay, hopefully you can already see an easy substitution. We let u be tangent theta, du secant squared theta d theta, which is right there. So we can rewrite integral as u cubed du. It's a definite integral. So let's substitute. When theta is 0, u is 0, and theta is pi over 4, tangent pi over 4, that is 1. This is just a fourth u to the fourth. Evaluate from 0 to 1, which is just a fourth. Simple as that. Okay, maybe I can even squeeze one more in over here. 38 integral pi over 6 to pi over 3 sine theta cotangent theta over secant theta d theta. Like in the previous problem, I don't like cotangents, so let's write everything in terms of sine and cosine, including this secant. Okay, so this would become, limits don't change, sine theta times cosine theta over sine theta. We've got to be careful there. And the secant is 1 over cosine. Okay, so let me draw a line there. This sine and this sine would cancel. This cosine we can move up, so it'll be cosine squared. And we know how to integrate this. Half angle identity. Okay, now we can integrate. So half theta plus half sine of 2 theta. Okay, evaluate from pi over 6 to pi over 3, which is half times pi over 6. What would be, this is 6, plus half times, what's sine of 2 times pi over 6? So that's sine of pi over 3, which is root 3 over 2, right? Okay, minus parentheses. We plug in pi. Did I just plug in pi over 6? Why did I do that first? So, then let's do the minus here, and then plus, so sorry, I'm not doing it the usual way where I plug in the upper one first. I, for some reason, plug in the lower one first. Okay, so I put the minus sign there. Now let's plug in the upper bound actually. So pi over 3 plus half times what sine of 2 pi over 3? That is also root 3 over 2. I think I need one more parentheses. And that should be your answer. This is a definite integral. Okay, let's move on. Okay, so 39, we have this integral secant theta tangent theta d theta over secant squared theta minus secant theta. Hopefully you can see a substitution. U is secant theta. Du would be secant theta tangent theta d theta. So our integral becomes du is just on top, and then u squared minus 1 is on the bottom. Okay, so how do we solve this? We can do it multiple ways. You could probably do a trig sub, but I'm going to do partial fraction decomposition. Like this, okay? So we can write it as a over u plus 1 plus b over u minus 1 is equal to 1 over u plus 1, u minus 1. Okay? Multiply both sides by the denominator, this denominator. So it'll be a u minus 1 plus b u plus 1 is equal to 1. We plug in u is 1. This would go away. 2b is equal to 1. b is equal to half. Plug in u is minus 1. This will go away. Negative 2a is 1, so a is negative half. Okay, so we can write it as a is negative half, so negative half times 1 over u plus 1 plus half times 1 over u minus 1, big parentheses, du. Okay, so this becomes minus half ln of u plus 1 plus half ln of u minus 1 plus c, this is an indefinite interval. We have to back substitute u is secant. This 1 half ln secant theta minus 1 plus c. That's what I get. Okay, so this one was pretty easy actually. You had to first do a substitution, then partial fraction decomposition, which is pretty easy. Okay, or like I said, you could probably do like a trig sub also here, and there's probably more techniques you can do, but I just showed you one way. Okay, and let's do another one. This will probably be the last one, and then I'll call it parts. Okay, integral 1 over square root 4y squared minus 4y minus 3dy. Okay, so how can we solve this one? Maybe let's just go down our list as usual. By parts, I kind of don't want to do that because it will be very messy, especially if, for example, well, we of course can't let dv be this guy because this is exactly the integral that we're finding. V would be exactly the integral that we're finding. So let's not do that. And if u is this guy, and then it'll become messy with the chain rule and all that. So maybe not that. Not a trig integral, not trig sub as of here. Now, maybe we can do something about it to make it a trig sub. Not a rational function, so not partial fraction decomposition. Can we make a like simple u sub? It's maybe you can, and maybe you'll get something. I'm not sure. So I'm going to go with the trig sub method. I'm going to complete the square. Okay, so to complete the square, there's a requirement that the term in front of, the y squared term needs to have a coefficient of 1 in front. Okay, so let's factor out a 4. Let me do it on the side over here to save some space, maybe. Okay, so let's factor out a 4. So it'll be y squared minus y minus 3 over 4. Okay, now we complete the square, so y squared minus y. So remember, it's minus 1 over 2 quantity squared, which is a fourth. So we're going to say plus a fourth. Plus a fourth. And then it's originally minus 3/4. So we need to put minus 1. Okay, so we can now write this as 4y minus half this guy squared minus 1. Okay, so let me write it over here now. Integral 1 over square root of 4 times y minus half squared minus 1. Okay, and actually we can rewrite dy. We can rewrite this as half, because the square of 4 times square of this other thing here, square of 4 is 2, so I can pull the half out as a constant. So let me do that. Okay. We can even do a little substitution to make it a little nicer before we do a trig sub. U is y minus half. Du is dy, simple as that. So it's half integral 1 over square root of u squared minus 1 du. Now we can do a trig sub. Have something squared minus something squared, so I know the first term is the side. Over here is the other side, this term, and then square root is the last side. Okay, so let's substitute everything here in terms of theta. I need u to get du, so let's get u. U is secant theta. Okay, secant theta is u over 1. So du is secant theta, tangent theta, d theta, and then we can substitute the square root term. What would that be? That is tangent theta from the triangle. Okay, now let's substitute. Du is secant theta, tangent theta, d theta, square root term is tangent theta. So our integral just is half secant theta. Half integral secant theta, d theta. This is just from the table. You should remember this. Secant theta plus tangent theta plus c. We had to back substitute. What is secant? Secant is just u. What is tangent? Tangent is the square root term plus c. You can always get it from a triangle, or we had it over here in our definitions. And then one more back substitution, because we have to substitute u as y minus half. So half log of y minus half plus square root of y minus half squared minus 1. Close the absolute value plus c. And that's what I get. Okay, so not too bad here. The trick here was I completed the square so that I could do a trig sub. Okay, so that's it for this video. Hopefully this has been helpful. These problems weren't too challenging. It's definitely tedious for some of them, but wasn't too bad compared to the last 3 problems that I did in the previous video. Those were much more challenging, and that's why I only did 3 problems in that video in the span of maybe 15 minutes or so. Okay, so please like this video if you found it helpful, as always. And please subscribe also if you haven't already. And please look out for the next part. Hopefully I'll see you in that video. Bye.